Assalamu alaikum. So, welcome to the online video lectures for the subject of HCI. Now, previously we talked about mental models and representations in our last lecture, and in this lecture we'll focus on the task analysis. So, let's dive into the details. So, in our previous lectures, we have already discussed the importance of tasks, that how important they are, and the main thing of this whole HCI is to make the user focus on the task more than the interface. So, the main aspect is to make the interface more visible so that the user can focus on the task itself. Now, when we look at HCI, we are actually looking at the tasks that users perform. We look at the tasks that they are performing now, and we try to restructure those tasks to be more efficient using new interfaces. Now, in all of this, the task is at the heart of the exercise. What tasks are they performing? So, in this lecture, we are going to talk about two methods for formally articulating the tasks that people are completing. First, we'll discuss human information processor models, especially the GOMS model, which focuses on the input to the user and the output of the user. Now, this is similar to the process or model of the user that we discussed in our human abilities lecture. The second, we will discuss cognitive task analysis, a way of trying to get inside the user's head. Instead of focusing just on the input and the output, note that that's similar to the predictor model that we again discussed in the human abilities lecture. Now, in the first part of this video, we'll cover the human information processor model's details, and in the second part, we'll try to focus on the cognitive task analysis. Now, the GOMS model is a human information processor model, so it builds off the processor model of the human's role in a system. The model gets its name from the four sets of information it proposes gathering about a task. Now, in this GOMS, G stands for the user's goals in the system. O stands for the operators the user can perform in the system. M stands for the methods that the user can use to achieve those goals, and S stands for the selection rules that the user uses to choose among different competing methods. So the GOMS model proposes that every human interact with the system has a set of goals that they want to accomplish. They have sent methods that they can choose from to accomplish those goals. Each of these methods is comprised of a series of operators that carries out that method. And they have some selection rules that help them decide what method to use and when. Now, GOMS model is often visualized like this. The user starts with some initial situation and they have a goal in mind that they want to accomplish. So they apply their selection of rules to choose between different competing methods to accomplish that goal. Once they have chosen a method, they execute that series of operators and make that goal a reality. So let's see a GOMS model in action. So we can take the GOMS model and apply it to a number of different domains. So let's take the example of needing to communicate a message to a worker. So we have an initial situation, which is the need to transfer information to a coworker, that carries with it implicit goal of the information having been transferred. Now we might have a number of different methods in mind that for how we could do that. We could email them, or we could walk over and talk to them in person. And we also have some selection rules that dictate how we choose amongst these methods. If we need to transfer the information and we understand that the transfer of the information is very time sensitive, so maybe we walk over and talk to them in person or call them on the phone, as it requires less number of operations to be performed. If the information we need to transfer is complex and detailed, maybe we write them an email. Or if it's more casual, maybe we chat with them or text them. No matter what method we choose, we then execute the series of operators that carries out that method. And the result is our goal is accomplished, the information has been transmitted. Or we could also take the problem of navigation. Our initial situation is the need to get to our destination, which carries out with it the implicit goal of having reached our destination. We might have different methods like take the scenic route, take the highway route, take the surface streets, and some selection rules that might say something like when it's rush hour on the highway, take surface streets. Or if it's not time sensitive, take the scenic route. After choosing, we execute those operators and reach our goal. So in this way, GOMS models capture our goals, our different methods for carrying out those goals, and the individual operators we use to execute those methods. Now let's see a design challenge for a security system, and let's discuss the GOMS model in this context. So watch this video. Watch a user enter the house, undo her security system in two different ways. After you watch the video, try to outline the user goals, outcomes, methods, and selection rules. Now, try to outline the goals, outcomes, methods, and selection rules for these two methods of disabling the security system. Try to model your own, and you can post it on Google Classroom, or you can email me so we can discuss about it. But let's see an example of how you come up with a probable GOMS model for this. So let's see an example of how you might design a GOMS model for disabling a security system. Our initial situation is that we are entering the home with the alarm set, and we have two methods for disabling the alarm. We can use the keypad or we can use the keychain. Either way, our goal is that we have entered the home and re-enabled the alarm. Our selection rules might be something like if we have our hands full, we are going to use the keypad so that we can get inside and put the stuff down. But if we don't have our hands full, we'll use the keychain. You might come up with other models for this that have either different methods, different operators, different selection rules. There are a lot of different ways we can capture a task with GOMS model, depending on what you choose to focus on. So let's discuss some strengths and weaknesses of GOMS. So one weakness is that it doesn't automatically address a lot of complexity of these problems. For example, there are likely many different methods and sub-methods for addressing this goal. Before even getting the selection rules among what route to take, you might decide whether to take public transportation or whether to work from home that day. In parallel to that, even after deciding to drive, you might decide what car to take if your family has more than one car. The standard GOMS model leaves those kind of things out. Although there are augmented versions that have been created to deal with this kind of complexity like CMN GOMS or in GOMSL, we'll talk about those a bit more later. A second weakness is that the GOMS model assumes the user already has these methods in mind. That means the user is already an expert in the area. GOMS model don't do a good job of accounting for novices or account for user errors. For example, if you are driving in an unfamiliar location, you don't even know what the methods are, let alone how to choose among them. The strength of GOMS models, on the other hand, is their ability to formalize user interaction into steps that we can use to actually make predictions. We can measure how long each of these operators takes, and so we can predict the overall efficiency of using a certain interface. For example, in the GOMS model, if we had included the operator to pull keys out of the user's pocket, we might actually identify that the relative efficiency of these two methods is very much dependent on how long that step takes. The keychain method might be a lot faster if the user can get their keychain out pretty quickly. But for the other users, the fact that they need to pull something out of their pocket while holding bags or holding a baby makes a keypad more efficient option. By performing that kind of reasoning, we can focus on areas that either method and the interface as a whole can be improved. Now let's discuss a paper which presents some of the techniques related to GOMS. So the GOMS family of user interface analysis techniques, comparison and contrast will be discussed in this slide. So there are several varieties of GOMS models. These varieties share the commonality of goals, operators, methods and selection criteria, but they differ in what additional elements they provide. Bonnie Jones and David Keras cover 4 popular variations in a paper from 1996. The first is the vanilla GOMS we have talked about so far, and the other 3 are KLM GOMS, CMN GOMS and NGOMS. Let's talk about what those acronyms actually mean. So they start with the keystroke level model, which is the simplest technique. Here, the designer simply specifies the operators and execution times for an action and sums them to find the complexity of an interaction. This method proposes 6 different types of operators, which are mentioned here: K, P, H, D, M, and R. Although for moderate interfaces, we would need some new ones to cover touch screens and other novel interfaces. A second variation is CMN GOMS, where CMN refers to the author's names Card, Moran, and Neville. It is an extension of GOMS that features sub-methods and conditions in a strict goal hierarchy. For example, here we see a hierarchy of goals, like this one, as well as ability to choose between multiple goals in different areas, like this. Notice also the level of granularity behind these GOMS models. The goals go all the way down to little goals like moving text or deleting phrases. These are very low level goals. Notice also the way this model is being used. The authors are using it to find the places where there's a lot of complexity that can be cut out. They do this by modeling how long each individual action takes, as well as looking at the number of interactions required and seeing if it can be cut down a bit. A third variation is called natural GOMS language. Natural GOMS language, or NGOMSL, is a natural language form of GOMS that lends itself to human interpretation. In all these cases, the important point of emphasis is the way that these models allows us to focus on places where we might be asking too much of the user. For example, in this model, the user was being asked to carry a lot of information in the working memory. By making the assumptions and actions and operators this detailed, this model acts as target where working memory is being overly taxed in a way that we might miss when we are doing higher level designs. Now let's discuss some of the tips for developing GOMS models. So the number 1 is to focus on small goals. We have used some pretty big examples, but GOMS is really designed to work in the context of very small goals like navigating to the end of a document. You can abstract up from there, but start by identifying smaller moment-to-moment goals. Number 2, nest goals instead of operators. It's possible to nest goals. For example, in our GOMS model of navigation, we could develop it further and break the overall task, navigating down to smaller goals like changing lanes or plotting routes. Operators, however, are the smallest atoms of a GOMS model. They don't break down any further, and those must be the actual actions that are performed. Number 3, differentiate descriptive and prescriptive. Make sure to identify whether you are building a model of what people do or what you want them to do. You can build a GOMS model of what people should do with your interface, but you shouldn't trick yourself into thinking that's necessarily what they will do. Number 4. Assign costs to operators. GOMS was designed to let us make predictions about how long certain methods will take. The only way we can do that is if we have some measurement of how long individual operations take. Usually, this is time, but depending on the domain, we might be interested in phrasing the cost differently as well. Number 5. Use GOMS to trim waste. One of the benefits of GOMS is it lets you visualize where an unnecessary number of operators are required to accomplish some task. That's bolstered by the cost we assign to these operators. So, use GOMS to identify places where the number of operators required can be simplified by the interface. Now, GOMS models are human information processor models. This method largely assumes that the human is an input-output machine. We already discussed this processor predict participant model in our human abilities. So, it doesn't get too much into the internal reasoning of the human. Instead, it distills their reasoning into things that can be described explicitly like goals and methods. Some would argue, myself included, that human reasoning is actually too nuanced and complex to be so simplified. They, or we, advocate other models to get more into what goes on inside the user's head. That's where cognitive task analysis comes in. Cognitive task analysis is another way of examining tasks, but it puts a much higher emphasis on things like memory, attention, and cognitive load. Thus, cognitive task analysis adopts more of the predictor view of the human's role in the system. Now, this conflict between more processor-oriented and more predictor-oriented models of the user actually gets at the core of an old battle in psychology between behaviorism and cognitivism. Now, behaviorism emphasizes things that could be observed, what we can see, we can see what input a person is receiving, we can see the output they are producing, and that might be all we need to understand the design of things. Cognitivism, on the other hand, suggests we can and should get into the mind of what people are actually thinking and how systems like memory and learning perception actually work. So take a moment and reflect on what you think about this. When designing interfaces, how much attention should you devote to observable goals, operators, and methods? And how much do you devote to understanding internal thought processes like cognition, learning, and memory? You can probably guess my bias on this issue, given that I have already badmouthed the processor model, and I have also focused more on cognitive systems in this particular class. So I am generally going to prefer methods that focus on cognition. I think it's important to note here, though, that both approaches have significant value. The GOMS model and its emphasis on identifying goals and operators is actually very useful in HCI because it forces us to very clearly and deliberately identify user goals and the sequence of actions that accomplish them. We can get so caught up in user experiences that we forget the user is born out of individual operators. So while I wouldn't advocate focusing solely on the user as some kind of input-output information processor, there's value in defining the user's operation as clearly and specifically as we define our computers. Now, in the next part of this lecture, we'll mainly focus on the cognitive task analysis. So, I'll end up this lecture now, which emphasized on more human information processing models like GOMS, and the next part will cover up the cognitive task analysis. So goodbye for now.